Assalamu alaikum and welcome to the second video in the series of BI process execution. So in the last video, I explained this whole templates that how we need to execute a BI project. So I talked about the steps that first we need to have the background knowledge of the domain that we are working on. Then we have this stakeholder problem matrix. We always start small by looking at one unique problem, which is the biggest problem that the business is facing. Then we list down the details of the problem and we write down the solution, what's in our mind, for example. Then obviously we identify the metrics that we're going to measure, the data that is going to be available to us. We can start thinking about that. And then we put the first blueprint of the story on the paper, and we write down the feedback of the colleague and how we made the changes. And then we obviously start with the understanding of the data. So now we get the data, and we understand the data manually and see what's the knowledge that it is giving us. And then obviously we have to wrangle the data very thoroughly. So that means we have to do descriptive statistics and inferential statistics along with data cleaning activities. So this also involves data mining, but it depends on how much you want to go ahead. And then obviously you draw your application. This is sort of an optional step. This is not very necessary during this phase. So this is when your whole solution is accepted by the top management, then you can think about that, and it's the IT's job to think about it, not the data scientist job. And then you interpret the results of wrangling, and then you actually do the brainstorming. So you modify the pipeline here if you want to modify, and you make a second iteration of your story if it is needed. Otherwise, it's not necessary. And you does talk about which type of dashboard you are implementing, and then obviously you implement the dashboard on the actual Power BI or tool, and then you talk about the takeaways, etc. So today I'm going to talk about the one of the applications of this template. This application is concerning the usage of electricity in the house in the context of a smart home. So the student that has done that, Umar Abid, he has tried to follow this methodology as much as possible, not uh, you know absolutely all the steps here, but I'm going to browse you mainly through the fact that what effect having this solution on the paper has on the final BI dashboard. That's the main thing that I'm going to talk about, along with the data wrangling part. I'm going to be sharing more videos of the work of other students, inshallah ta'ala, which will cover the aspects, all the aspects of this methodology from time to time. So this is the report that was shared by the students. So the data is downloaded from this Kaggle website, Smart Home Data Set with Weather Information. The BI tool used is Power BI. So the first thing they did was to get the business knowledge, and the business knowledge is telling them, the smart home technology basically comes in two flavors. One is that we have a central control system, and the other is that we can control through the mobile app. Okay, so we can control different devices through a mobile application. So these are the two models that are being used. And now currently what's common is that you control these smart devices through hubs. So the hubs can, connect to, they will allow you to connect to any device through an app. And then they present you an integrated interface for monitoring all the apps, all the devices or the rooms together. So that's the common way of doing things. And probably this data that they have downloaded has been done using the same source. The data has been acquired by using the mobile applications. So connected devices communicate with each other and us. So that's the main thing, that the devices are all connected to each other. Any electric device can be joined in the network or the IoT network. Most of the devices are related to lighting, home security, entertainment, thermostat regulation. So we have already seen We know about the high consumption of the fridge, microwave, iron, AC, etc., etc. So all of these things are, much more measurable than the other ones like fans. And we can control these devices through interfaces. IoT is the central idea, and there's a boom in smartphones and tablets that allows us to control these devices very easily, switch them on and off, etc. And the current systems use radio waves to communicate with the smart devices, including cameras, LED lights, motion sensors, doors, etc. So this is basic general knowledge about the technology, that what's happening. Okay. The next part is, what the others have done. So these guys looked up some sample dashboards on Google Images, that what the other people are doing. So basically what they found out was that the general trend seems to be that the smart home analytics dashboards are focusing on the energy usage trend. So people basically want to see that, okay, what is the consumption pattern of the energy of a particular device. So that's what they basically want to see with respect to time, obviously. So that's why we can, most of the charts they saw are using either line charts or area charts. And then obviously we can drill down with respect to each device. So when we drill down, then we can either show the results on a donut chart, which is better than a pie chart, obviously, or we can use a simple bar chart, whether it is vertical or stacked. If you want to show two or three different things together, either vertical or horizontal, stacked or clustered, that's up to you. So that's the basic type of analysis that people are doing. So that gives us an idea what we should do. And then obviously people are also analyzing the cost, that what is the cost that has been incurred by this electricity usage. So that's what they want to see, how much money I have spent on it, or basically if they also see how much, the total electricity has been generated and how much has been consumed. So we can calculate the cost that we have incurred and the cost that we have saved. Okay, because if the consumption is less than what is generated, then we have saved some money, right? So that's one way of thinking about it, but we can also think of other ways in which we can save the money through electricity consumption. And then obviously some people have done the forecasting as well to forecast the usage of electricity over time. Some people show this weather data as in the form of scorecards. So what is the temperature, what is the humidity, etc., etc. So they show that in the form of scorecards. Many dashboards explode on power consumption with respect to appliances and room using charts like donuts and bar charts. So basically the trend seems to be line charts or area charts, and then donuts and bar charts for a bit of drill down. That's what the trend seems to be. And what these guys did was that they skipped some of the questions that I asked in the that I specified in the template, but they specified the problem, which is the most important thing, to analyze the efficiency of smart home energy utilization, uh, along with the data on how to improve the energy consumption. So that's what we basically want to analyze. And obviously they then got the data. So we'll first go through the data here. So this is the data that has been downloaded from Kaggle. So you can see that we have the timestamps here. So this time is like per minute interval. So we have a total of around 500,000 intervals. So this seems to be an error here, the backslash. So we'll deal with that in the wrangling stage, I guess. And then obviously we have the total consumption and the total generation of electricity, and the overall consumption in the house. Then we have the different appliances like furnaces, dishwashers. We also have the rooms. Then we have the fridge, the cellar, which is also like a room, garage door, kitchen, which is a room again. So we have a kitchen 12, kitchen 14, kitchen 38. That seems to be quite a big house. We have a barn here. In fact, this could be a big building. We have a well, which is a microwave, living room, the solar consumption. And then obviously from the solar consumption, we start with weather related variables like solar temperature. We have the humidity, the visibility, the apparent temperature, and the real temperature. Okay. The pressure, the wind speed, wind bearing and precipitation intensity, dew point, and precipitation probability. So we have like maybe 9 to 10 variables related to the weather, and we have the other variables related to the measurement of electricity consumption, and then we have the time, and we have three variables which are related to, which are actually categorical. So you can see here that we have this cloud cover, but you see that cloud cover variable mostly consists of numerical values, just one cloud cover value. So if these rows are not that much, then we can replace them. We can convert them to missing values, and then we can replace them using any logical formula, because we can't have, this is definitely not a string variable. So this seems to be some sort of an error here. So we'll deal with that. The students have dealt with that, in fact. So, and the other variable is icon. Icon is telling you the weather information as well. As you can see here, cloudy, foggy, clear day, clear night, etc., etc. But the main variable here, as specified in the report, is the summary variable, which is telling you the actual weather condition. So this is what is most important, I guess. Breezy, breezy and mostly cloudy, breezy and partly cloudy, clear, drizzle, flurries, etc., etc. So we have like maybe 10 to 15 different discretizations in which we can determine the weather, in which these the actual weather in which we recorded these pressure, temperature, etc., and the measurement of electricity consumption and generation at each in each minute, in fact. So when we, when the student browse through the data, so um, what message it gives us? It gives us the message that we have the consumption data, we have the generation data, we have the weather data, and all that remains to be seen is to analyze it. So the student already has an idea of what the analysis will be, because they have seen the other dashboards already, and they have written down the problem that they want to analyze the consumption. So the next steps is definitely that you draw the proposed chart on the paper. Okay. So let's go back to the report here. So if you see here, this is the first snapshot that has been drawn by the student Omar Abid regarding the electricity consumption. So this idea could be strongly derived from the fact that we have seen these 10 related dashboards, and now that we have seen our data as well. So in our data, for example, we don't have any cost, that how much cost we're incurring. So we can add the cost here if we know how much is the charge per kilowatt hour or per kilowatt hour per minute. So how much is the charge? So we can add the cost for that. So what they have done is that they drew this scorecard in which they entered the weather related information like we specified here, so they took the idea from here, so they put it here. We have the weather related information, so we can add this, right? And then we have this hourly energy generation, consumption, and cost. Okay, so these are the three gauges in which we have this some sort of threshold as well that we want to achieve or avoid in all the three cases. So we can have these gauges here, and then we can have obviously the consumption chart, which can be a line chart or an area chart. And then we can have these donut charts for different appliances. We can have this time-based forecast chart as well. And then on page 2, we can have this waterfall chart of cost with respect to time. So how is the cost varying with respect to time, along with the predicted cost. So if we do time series analysis or time series forecasting, then we can forecast the cost for fridge and air conditioner, etc., etc. So that's a very good diagram, because it summarizes the weather information here. You can have some filters here as well for a more robust dashboard. So the idea of all of this is has been gotten from this one and from the background knowledge. And that is the thing that I want to stress in this methodology, that if you know how the data has been gathered, and if you know what the others are doing, what sort of charts are there, dashboards are there, what are the analysis, if you spend some time on these two things, then you will be able to identify the problem when you see the data very, very quickly, and you will be able to develop this story in a very small amount of time. Just with just a few iterations, you can have this first view of the dashboard. And the story being told here is pretty simple. So they have written down the story here. The story starts by providing users some weather-related information, so that we can analyze all of these charts with respect to the weather that is listed here. So I can have different weather conditions. I can select different weather conditions and see how the consumption is changing. So that is the story here. And then the three gauges, they talk about the important metrics that we have seen already. And then obviously we move on, we drill down from these gauges to here, which is the actual room that is there. And we can also move to the actual device, and we can make a forecast for each room or each device. And based on the forecast of the cost, we can also add the cost. So we can make a forecast for the consumption, and we can make a forecast for the cost. And based on the forecast of the cost, we can have this donut chart which tells us, okay, which appliance has the highest predicted cost for the next hour, or for that matter for the next 2 hours or 5 hours, whatever your time frame is. And we can see how the cost is varying with respect to time for different appliances through this waterfall chart. Okay. So on page 2, so we already saw what this page 2 is offering. We discussed that. So this is there before even we look at Power BI. Okay, that is the main thing. So we can derive the idea from there. And now, before I discuss what they did, so let's go to this the wrangling part, which is I want to stress as much as possible. So in the wrangling part, wrangling consists of basically descriptive and inferential statistics, along with some data mining techniques like regression, uh, decision tree analysis. For example, you can also use that, correlation analysis or covariance analysis. So that's a lot of work to do. So in any case, we'll see what they use. So they imported the data. They saw the shapes. We have 32 columns. So they saw just the first few rows and last few rows. So we can see that there's an error here on the last row. And it's just one value which is missing, which is the last row. So we delete that. The nulls are present in the last row. So we just delete drop NA. So that is going to delete the last row. And now we don't have any missing values, as we can see from here. Then we see the types. And when they try to convert from this unit M to a date time format, so it gives a problem. So they generated their own date according to the information which is given on the website. So they started from this 1st of January 2016 at 5 a.m. And then you just keep on adding the hourly data time stamps, and what we have is here. Okay. Oh, sorry, the minute time intervals at every minute. So, but we add the minute, and then we have this. We can have all this information. Okay. So you start in 1st of January and you finished on 16th of December. So that's data for like 1 year. Okay. So cloud cover, we already saw that there's a problem. So what we do is that we replace cloud cover by np.nan. And then we see that how much is just 0.0115% of the whole column. So we just replace that by the b fill method, which is the background fill method. So it takes the first value and fills it up all the way to the first nil value, because it's the first value in the data, the cloud cover. It's the first value in the column. So b fill is going to take the first valid numerical value and fill it up all the way up to the 0th row. So that's the bfill method. So we fill that up, and now it's converted to a numerical column. So we can drop these columns because they have extremely similar, data according to the data that is there. Yeah. So use and solar are exactly the same, and uh, exactly the same as some other column. And icon column, we can see we can drop because we have the summary column which summarizes the weather. So we don't need the icon, because the weather column, the summary column is derived from the icon column. So we can delete icon as well. So now what they have done is that they have added a cost. So they know the cost, kilowatt hour per minute cost in PKR, that is being done by K Electric just a few months ago. So we can have a cost incurred variable which multiplies the rate with the overall consumption, and we can also have the cost saved at each minute, which multiplies the rate by the generated electricity in that particular minute. So we add the cost because we have the idea from the other charts as well. So we add the cost ourselves. So now it looks good. And now what we do is that we come to inferential a bit. So in inferential, they just do one analysis that whether the overall consumption of electricity and the energy generation is related to the weather. And in both cases, they found out that the p value is very highly significant. So that means the overall consumption and the overall generation of electricity is different across, is significantly different for different weather conditions. So that's also what we expected to see. So that means the data is pretty reliable. And then we can also have this correlation heat map, which is pretty famous now in Python. So we can see that we can look at these areas where the dark circles are there, which represents areas of high correlation, high positive correlation, or some very red areas which represent areas of high negative correlation. So for example, we can see that the humidity here is correlated strongly with the, yeah, so sorry about that. The humidity is correlated strongly with, for example, the visibility. Okay, or the cloud cover variable is related strongly with the visibility. So so we can draw different conclusions as we deem feasible from this. So the conclusions that can be drawn basically depends on the mindset of the analyst. So I'm not really sure what the students were thinking here, but they probably drew some information from this which they used in their actual Power BI dashboard. And then they did a very guns blazing type of t-test. So in the t-test, what they did was that they compared the mean value of electricity consumption of the different appliances and rooms. And you can see that in all the cases here, the p value is coming to be highly significant. So then that means that the mean consumption of the different rooms and the different devices are all significantly different from each other. So this is a specific type of t-test which measures differences between the means of two columns. And in this case, we don't see any value which is not significant. In fact, all the t-test results are highly significant. Especially you can see here that the well and the microwave. So it's a very highly significant relationship. So then that means there's a world of difference between the consumption pattern of the well and the microwave, which is also understandable. And that's pretty much it by them. We could have expanded it more, but the main thing is to understand that we first got the knowledge, and then we saw what the others are doing, then we saw the data, then we knew what has to be put on the paper. So we just designed the paper like this here. And now this is the time to, on the paper, the guys are going to give you the feedback like I discussed in my video. So you can have the feedback on this. So they can say, okay, you should include that, or you should exclude this, you should add this, etc., etc., make this more legible, replace the chart here, spread it over 3 pages, where are the filters, etc., etc. So all of this is going to make this chart even better. And now when you come to this actual chart that they made, you can see that there's a lot of mapping between what happens here and what is happening here. So they still have this weather related information which is there in the data as well. So we can, based on some filters, we can obviously change that. We have this the same gauges: electricity generated, used in the last hour, home office usage last hour, and living room. So the students think that these two are more important, so they put it here as a gauge. And then appliance usage by month. So how are the different appliances being used across the month? So here they are the names of the appliances, and then we have this ribbon chart. In fact, so we can see that the living room consumption basically remains very high, except for some periods in June and let's say September, for example, it falls down, but otherwise it remains very high. Which is followed by, for example, this pink one. I don't know what is the pink one. We can't see it here. But now it basically tells us that how is the consumption pattern varying for the different devices and different rooms. We can have two ribbon charts here. And this ribbon chart is very synonymous with what we wanted here for the cost one. So this is the waterfall, but now we are having this ribbon chart for the consumption. We can also have the ribbon chart for the cost. Okay. And then over the different months, because we have 12-year data, So sorry, 12-month data. So we can have this chart over the whole year, and it allows us to say the electricity usage and the generated. So it seems that the usage is always more than the electricity that is generated. Okay, so that's a bit problematic. I don't think so that there's a problem in the data, but that's what the data is telling us. So now we have a very clear idea that based on this, you know, so this when we have these weather variables, so we can see what is the consumption pattern and the generation pattern of electricity. And we can also see, for example, based on this weather selection, what is the consumption pattern of the different devices and the rooms over the whole year for this particular weather condition that I've selected here through some filters, for example. So I can have the filters. They have not demonstrated the filters, but if I change these filters, so for the different weather conditions, I can easily monitor the generation and the consumption and how the trends are changing here. So this is a pretty useful dashboard, and the story is absolutely clear. The story is extremely simple. That we make weather as the main dimension here. We can also form a hierarchy if we want. For example, we can say that the snow is the most generic level, and then we can follow that up by rain and heat. Or if it makes sense to form a hierarchy, we can do that, and if it does not, then we should not do. But based on this filters of the weather variable, all of these other charts are going to change, and that's where we can see what is happening. Okay, and this is the second dashboard here. So we can see that the weather summary here, electricity usage total and generated by weather summary. So generated is pretty less. It's on the top. It's a stacked one. So the generated is always less than what is uh, the consumed one. So in the clear weather, we have the highest consumption, and in the other weather we have the lowest one. So in dry weather, breezy, both the consumption and the generation are pretty limited. So average of electricity generated by dew point. So now we come to this, we come to this stage in which we can start now drilling down through different BI charts. And this is, the guys had some constraints obviously due to the time of the project. But now, based on different humidity conditions, based on different precipitation conditions, based on different temperature conditions, we can see the generation, how the generation of electricity and the consumption of electricity is varying. That's the main thing. And then obviously, this is the cost analysis. Electricity cost in the last hour, and the cost saved in the last hour, and along with this is the way the cost is changing. Okay, so they have tried to form this story, but you can now envision that how you can modify this in literally thousands of in hundreds of different ways or tens of different ways. With based on any selection of weather, these things is going to change. So I can monitor the consumption and the generation and the pattern of consumption for different types of weather separately, and try to make a strategy for optimizing my electricity usage. And then obviously I can have these line charts which tell me the generation with respect to the whole year and the consumption. I can also see them both together through the stacked option, and then obviously through the different weather variables. I can analyze my KPIs here. So that's another line chart that I can have. I can also have a scatter plot, and then I can have many different charts for the cost analysis. So here in this report, they just try to give an idea. Okay, so how the analysis can proceed. Obviously, this is not a full-fledged or a full-blown BI project of the industry, but the most important thing to acquire from this whole exercise is that when you spend time on these two activities, and when you spend time on the wrangling part, you clean the data, you understand the data, what is in there, then it becomes a piece of cake for you to design the dashboard based on what you have done here. Okay, so that's the main thing that we want to understand. And besides that, the group member that you have is going to help you make some contributions. So Omar is telling that Mars helped me with streamlining the overall story that the dashboard is showing. There was guidance regarding the color scheme, helped in page 2 of the dashboard when making the relation chart of energy generated with respect to dew point. So probably his partner gave him the idea that we can analyze KPIs across different weather variables, helped in making the calculated measure of the net cost, how the net cost is made, validated the story, helped in finding various codes for different statistical tests, and etc. 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 And how this guy contributed to the other chart. Okay. So for the cost, we just multiply. We have already seen how the cost is made. So that's it from my side today. Inshallah, I'll be back with another example of this methodology to show that it gives you a pretty good head start in zoning in on a very good dashboard, and then drilling it down further from there. So this is far from complete, but this is the first prototype, you can say, which is still telling you a lot of information about the different appliances and rooms and the cost, obviously. But now you can drill down from here by adding the relevant filters and zoning into the problem that you want to solve exactly. Okay. Thanks a lot for your time, and I'll be back inshallah with the next video.